Then I'm going to share my screen so we all looking at the same. Okay, room 1. Zach, Ian, and Layla, talk to us about what you want to be doing.
I can start. So we all decided on our coffee filter numbers. We went with more of a lighter choice just because of for time reasons. We didn't want it just to hit the ground immediately because the more weight, the more it will go down. We decided for what we would measure. Our first thoughts are speed, mass, and weight, just to get some basic measurements, and then Layla can talk about how we'll measure it.
Yeah, so for how we'll measure it, we thought that we'd use Vernier since that's a good resource that we have, and upload videos of us dropping our coffee filters and do this like a couple times so we can have a few videos and lots of data to analyze. And then we can use Vernier to analyze our data, and then to find the mass of it, we thought we could use a spring scale as well. And then what we think that this will give us like the information of enough data to like make a graph, and then to see if the velocity is constant or not. And if the velocity is constant, then we will know that the forces are balanced, and that means that the drag force has to be the same as the gravitational force. So we're going to use that information to kind of try to find the answer depending on whether it's constant velocity or not. And we also know that the slope is the velocity, so when we make a graph, we can also analyze that.
Okay.
We also did some research about how to find the amount of drag, and so we have on the right we have some of the values that we need to figure that out and to be able to get to that value.
So the cross-sectional area, the drag coefficient, and the density of the air. Okay. Awesome. Great. So that's one way to do it. Here's another way to do it. So room number 2, Jordan, Ruby, and Ronan.
Well, our way is not really another way. It's kind of similar, but yeah, like the other group is doing, we're all going to use 5 coffee filters so we can compare our data, and we're going to measure using spring scale to find the mass/weight, and Vernier to analyze the speed that the coffee filter drops. And ours wasn't super thorough on Wednesday, so we tried to add a little bit more, but we didn't really have a lot of time. But we're going to measure the speed, the weight, and the mass, and that will give us the numbers that we need to figure out, or we need to use to figure out the drag.
Okay. Excellent. Jordan, Ronan, anything else you want to add?
No, I think Ruby covered it all.
Of course she did. Ruby, can you turn on your camera too? Okay, room 3, Marlo, Gio, and Eliam.
Okay, so first, we said that we're going to use 5 coffee filters at a time for our experiment. And then we also established what we will measure, which would be the speed, the velocity, the weight, the mass, and of course, using units, which would be kilograms and newtons. And then
yeah, so we're gonna measure it by using our spring scale, the video analysis thing to analyze our video, and a Google spreadsheet in case we need to like make a graph. And it's gonna give us the net force, friction force, and gravitational force.
Some questions we had were, do we have to know if the speed is constant? Is there a normal force? And is there an applied force? And then once we make a graph, we'll be able to figure out whether or not the speed is constant or changing.
Okay. Excellent. So that's group 3. Group 4, maybe? Is that the group? Is that? Any group want to take ownership of that one?
I can. Okay, so what we did was we're all doing 4 coffee filters in order to have the same amount, so we can compare, see if like if one person has a difference but 2 others are the same, we go by what the 2 others got. And we know that the drag force of the air on the coffee filters will equal the gravity force, assuming the velocity is constant. So what we're going to do is we're going to measure for constant velocity with vernier. If the velocity is constant, it's going to make things a whole lot easier. But if it's not constant, like the coffee filters like float and just if the velocity isn't constant, then we're going to have to use some alternate methodologies. But we're also going to measure like with the lowest tier spring scale, we're going to measure how much it weighs. So we can measure the force of the drag force, which is going to be equal, assuming the falling velocity is constant.
Okay.
And yeah, we'll be able to figure out that the one we measured on the spring scale and the drag force are equal if the velocity is constant.
Got it. Who else is in your group, Mark?
Noel and Dakota.
Noel and Dakota. Noel, Dakota, anything you want to add?
He pretty much said everything.
Pretty much said everything. Got it. Ollie, Reed, and Casper.
All right. So for our group, we all decided that we were going to go with 5 coffee filters, just a nice even number. We will measure the speed of the coffee filters falling as well as the weight of the coffee filters. And I think we're using vernier for that. Wrote that down there. We will also use a spring scale to determine the weight of the coffee filters by just, hooking it on. And then that'll give us speed and weight. And then we can use the speed and weight to figure out how much drag is on the coffee filters.
Excellent. Reed, Casper, anything you want to add?
Nope, I think that covers it all.
Okay.
Yeah.
Okay. Is there anybody else after that? No. Okay, so now comes the fun part of this. And we're going to try an experiment. I did that with my other section and it was pretty successful. I'm actually not going to call on people. So I'm going to ask you just like if you have questions or if you want to say something, just say, right? You have seen all people's plans. They're all kind of similar, which kind of makes sense. This is like, how we train you to do this experiment. So it's normal that you would all have sort of like the same flavor of experiment, but you all have like slightly different conditions. This is time for you guys to ask questions of each other, to push each other a little bit, to develop a better plan, right? Things that maybe there's some things you haven't thought about. So I don't know, anybody who has any questions? Yeah, just speak, right?
Yeah, I was wondering if you think that it matters what height we drop it at or not, if we should drop it at a consistent height or.
You gotta think. Does it matter at what height we drop the coffee filters? Ooh, the big chill. So, Leila, that is a great question. And you guys will have to figure that one out. So you guys all came up with around like 4, 5, 3, whatever, 6 coffee filters. Does it matter that you, in a group, does it matter that you all have the same number of coffee filters? Ian says no. mean, I guess my question is, are you and your groups intending to share your data? Like, are you going to average data or not? Or is everybody doing their data individually and then it sort of doesn't really matter, like how many coffee filters you use? Like, what's your thought about that?
I think that if we are sharing our data, then it would make sense to have all the same coffee filters, or at least if we're just gonna like compare to see if one person's data is skewed, that would make sense to have all the same. But if we're doing it separately and not going to compare or share data, then it doesn't matter.
Yeah, Ronan, just speak.
Oh, well, just for my group, we're all doing the same data, not because we're like gonna like combine all of our data into one, but it's just like Layla said, to look over each other's data to make sure one of us didn't make a mistake or anything.
I like that. Couple thoughts. I'm the one who packed all the science kits. I'm here to tell you that you don't all have the same coffee filters. So just FYI, there are at least 2 sizes of coffee filters, right? So it's possible you don't have the same coffee filters. Here's a coffee filter that came from my kit, right? Question, this coffee filter versus this coffee filter, it's the same coffee filter, right? Are they going to fall the same way? Do all of your filters are equally crumbled or not? Yeah, Reed, what do you want to say?
I just, well, they're not going to fall the same speed because one has more, you know, air friction or drag on it, and then the other one has less.
Mm-hmm.
Yeah.
Yeah, so you want to be a little bit careful, right, about how you, I mean, I'm not hearing a big motion of like, we all want to like pull our data and like make averages, right? If you're going to do average, if you're going to do averages, the question you want to ask yourself is like, what are you going to average? Are you going to average like the time it takes for your coffee to fall? Are you going to average the speeds? Which speed? The top speed, the middle speed, final speed? Are you going to average the weights? Are you going to average? Do you need mass and weight, or mass or weight? Do you need to know how far the coffee filter fell? That's another one. Another thing is when you're taking, so the one reminder, when you're taking your video, make sure that, so if you think about the coffee filters falling along a wall, right? Make sure that your video is perpendicular to the wall and that your camera is centered kind of like in the middle of the trajectory. So you have like, so it's not like, don't put your camera at the bottom of the trajectory, you know, so it's, because then there's going to be a lot of sort of, what's it called? Distortion at the top, right? So you want your camera to be sort of centered with what's going to happen so that it sees most of the motion, right? So that's the one thing that I want you guys to be careful about. Okay, so any questions for any of you? Like for me, for you, for like what's, you feel pretty clear about what you're doing? Dak?
Are the coffee filters heavy enough to like actually make the spring scale go down?
That is such a beautiful question. Yeah, I don't know. You're gonna have to figure that out. Yeah, and then if that doesn't work out, then you need to start thinking about, so let's say they're too small, like you're gonna need to figure out a different way of measuring your mass or your weight, or, right? And there are ways to go around that. Make sure when you use your spring scales that you zero your spring scale using the little knob at the top, right? So make sure that when it's hanging with nothing on it, that it's indicating 0. That's going to be important. Okay, gonna stop sharing.